Hello. Welcome to theme number 2, climate change and how does it affect your heat treating operation. My name is Don Martini from Seco Vacuum Technologies in Meadville, PA. I will be your host for this session. I'll be joined by 3 guests. First is Mr. David Scharf, Senior Heat Treat Process Engineer from the Scheffler Group, USA. Second is Dr. Solomon Berman from IBC Coatings in Lebanon, Indiana. He's the owner. And Mr. Rafael Valchak, Product Manager at Seco Vacuum Technologies. Welcome, David, to the conversation.
Don, good day. Thank you for having me.
David, could we start off for a moment with you telling us a little bit about the Scheffler Group and just at a high level what your involvement is there?
Absolutely. Yeah. So the Scheffler Group is a global company. We have a very large presence in the bearing industry. We're an aerospace, industrial, and automotive tier 1 supplier. My involvement with Scheffler Group, which, by the way, I went straight from college to the company. It's a fantastic company. I'm responsible for heat treatment in the American region. So this means North and South America, Brazil, Mexico, USA, and Canada. And my typical day-to-day there is production development, technology development, deploying capital, and production uptime. So making sure that our operations are running efficiently and that all of our heat treatment is being supplied in a quality way direct to the customers.
Oh, great. So your involvement in the heat treating operation is deep, shall we say? And speaking a little bit on climate change, what's the meaning of that to you in your position? And I mean, does it just mean simply that the heat treating shops are warm or getting warmer, or is it something bigger than that?
They've been warm for a while. We see a little bit of an exodus in the summer months for that reason, but that's why I enjoy heat treat. I'm one of those crazy guys that likes the 110 degrees in July working on the shop floor. But yeah, climate change, it's garnering more and more attention as of late, as it should. To me, it's absolutely a global challenge. I think the only way that we manage it is by partnering globally with other plants, other engineering teams, other companies, etc. So we've seen the effects already that climate change has had or is having. This will and already is affecting us in production, I would say. So things like lack of water, cleaning and heat treat, grid strain, those types of things. And I would say even more severely in the supply chain, the effects on interruptions that it could have. So like I said, it's a global effort required for us to manage it and to be net zero by 2050 as laid out in the Paris Agreement there. We've agreed on ambitious climate targets as well as flow down to some of our suppliers and sub-suppliers. So the way that we're managing ourselves and our providers is in a team way, so everybody's moving towards the same goal.
Dr. Berman, could you take a moment and tell us a little bit about yourself and your business?
So I started IBC back in 1996, and we started with surface treatment, surface engineering, and we grew here in Lebanon, Indiana, from pretty much 1-2 people to around 100 people. Today, IBC is a group of 2 companies, IBC Coatings and IBC Materials, covering surface engineering in different sectors of our industry, from airspace to agricultural, in heavy industrial, automotive, medical, pretty much any sector, oil and gas, you touch, IBC has their customers and their applications over there.
So Dr. Berman, can you tell us a little bit about your general understanding of climate change?
From the get-go back in when we started our business, we were extremely careful and paid a lot of attention about the source of energy that we use. And it wasn't a matter of just occasionally it happened as it happened, but it was a matter of choice goes electric. And as you can see today, all our equipment, all our furnaces, everything is electric. And the choice was, our first furnaces came from Seco Warwick actually, and the choice was to do vacuum heat treating and not oil quench and everything else. And as a matter of fact, the first furnaces were right away 12 bar quench. So we were foreseeing the need for high pressure quench. And really it was the right decision because definitely the prices of gas were fluctuating, and sometimes it was very, very kind of challenging to continue with the electrical prices when the gas seems to be so cheap. But in the long run, I think it was the right decision for the company, and we see that focusing on the electrical heat definitely helps the environment. Definitely, we do not believe that without taking care about our planet, we can really succeed and have living a good future for our kids and grandkids. So, and one of the factors is definitely the pollution, is definitely the carbon monoxide that we are pulling out through burning gas burners in the furnaces and just not controlling our environment. The other aspect is also definitely our nitriding processes, where we intentionally did not go with the gas nitriding just due to a lot of burn off of the methane and again contamination of the atmosphere. And we went with the iron plasma nitriding, where we really use environmentally friendly gases and have really no pollutions, and the amounts of gases that are being used are considerably less than what is being used in traditional gas nitriding. And it is true if we look at the changes in the technology and the impact. And again, I'll give a good example of Seco, of the advanced technology that Seco was done using the zero flow, trying to minimize the impact of the pollution and the need to burn off the gases coming out. But still, the choice of the plasma nitriding was not a random choice. It was a choice to focus on the environmental issues, to have the most advanced green technologies in our heat treat world.
So if we look specifically into heat treatment world, what are the major emitters of pollutions to the atmosphere, in your opinion?
Heat treat is it's heat and atmosphere on a basic level. That's the first thing I was taught day one. So in that aspect, it's going to be the process heat, obviously. So gas-fired or electrically heated equipment, and then it's the atmosphere itself. So whether that's endo, nitrogen, methanol, propane mix, it's probably around 8% the heating. It's the contribution to the emissions, and then about 15% we say is the atmosphere.
So in my opinion, definitely it's the gas heating is the pollutant number one. The other one is a lot of salt bath processes, including salt bath nitriding, including anything that requires the following cleaning, washing of the parts, where the pretty much the water that was used becomes contaminated and requires or evaporation, that again is being done not in the best environmentally used best way, plus having the hazardous materials disposed. So these are pretty much majority of the processes that are, from our point of view, affecting the environment.
Continuing on that subject, so what technologies you see as a potential reduction of the CO2 footprint?
Definitely, if we are looking at new technologies or technologies that are coming up right now, we started to focus also on laser hardening. And this is a great replacement for pretty much flame hardening, providing excellent environmentally friendly solution that does not require pollution. So there is no need for gas, for flame, and all that. So that's one of the areas that the technology definitely advances. The other possibilities are still in the advancement of iron plasma nitriding, carburizing, trying to replace vacuum hardening with definitely high pressure quench, all the way trying to replace the gas processes, trying to make the vacuum processes more cost effective, higher volumes, higher throughput, so that pretty much they can be used in the automotive. And then definitely looking into the design of the steels that are being used. A lot of work was done in the airspace when there are targeted alloys, and in today environment where we have companies like Questech that can design a system based on pretty much analytical prediction how the elements will behave and target the performance. I think the industry should look more into doing that instead of just copy paste, take the alloys that were used 100 years ago and just blank move them into the new automobiles and other applications. So that's something that has to be addressed.
So are you trying to tell that there will be materials, metallic materials, which will not require heat treatment or require less heat treatment in the future?
So number one, there should be materials that will be easily be heat treated using the vacuum technologies and electrical heat and vacuum gas high pressure quenching. So if today we're all struggling with 4340 or 4140, trying to get the hardness just using 20 bar quench or 25 bar quench, trying to use helium and all that, the real solution will come when the material will be addressed and the design of the steel will be addressed so that we can have the properties that we have from 4140, but the material will be quenchable in normal way, where we can use just easily available nitrogen, quenching at normal 10 bar, 12 bar speeds and providing the properties that are required. So that's my view of just going forward. It's a mutual effort. It's an effort from the material providers together with the heat treat industry and together with the whole community.
Do you see any other changes in manufacturing process which can possibly reduce the emissions in the future?
Yeah, so there's a lot of things we can do to existing processes. Cleaning is integral to heat treatment, so very, very popular, not just with our company and the industry now, is development and implementation of ambient cleaning. So this means taking processes that are 50, 60 Celsius heated, whether it's solvent or aqueous cleaning, and switching this to room temperature ambient cleaning, so we can get rid of the electrical consumption in the cleaning process. This is a big focus for us now.
Obviously, it goes beyond that. You know, when we talk about suppliers, and you mentioned a little bit about them or your customers, do you see activity among them? You know, are you specifically, let's start with the supplier side. Do your utilities approach you and say, look, we have an incentive or a program that we're conducting right now that would allow you to, or we'd help you evaluate your usage to find areas that could be improved? Do you see anything like that on the horizon, at least from a, from a utility standpoint?
So it's a very, very good question. So there are a couple things that are going on right now in our local Indiana community. So number one, last year, we actually did an energy survey that was subsidized by the state and performed by IUPUI that mapped all our energy efficiencies and inefficiencies. So that was one important step that concluded with a solid report with recommendations and all that. We've invited a solar company to come out and provide us with a quote to install solar panels on our roof because, again, our energy, as you can understand, its main source of everything that is moving in our plant. So we got a quote from them. We also contacted battery manufacturers that will provide us the supplemental batteries. Now, unfortunately, being in Indiana, it's not enough for us to create enough power, for example, to feed our equipment or have sustainable impact on how much power we can use. However, we look at that from absolutely different perspective. So today in our facility, we use gas-fired furnaces for the winter time. Definitely not in the heat treat area where we have constant heat coming from the temperate parts and all that, but the rest of the company. So a general decision is being made to switch to heat pumps and to power up the heat pumps from the panels that will be installed on our roof. So we'll be sizing the panels and everything else for our heating needs for the winter time. And as the progress with the heat pumps goes on, we'll be looking into replacing also cooling units with the heat pumps. So today, the first heat pumps will be actually installed next month in our facility, and we'll be moving in this direction, just improving the efficiency and again, just putting our little as much as we can into global warming and reducing the energy impact.
Very well. So it's not just about your core business, but also say the related costs to operating, right? You're
Correct.
offsetting some of the costs and becoming more efficient in your overall business practice through.
Plus, we are getting rid from again the gas-fired heating furnaces. Just we'll go to the heat pumps that are more cost-effective and efficient.
We're definitely working with our vendors. A big supply to the heat treatment industry is the steel. So the casting, forming, forging processes, whether you're buying cold rolled steel, billets, bar stock, things like that. So contractually, we're seeing this show up in those discussions with our suppliers. So we want that not only Schaeffler is climate neutral, but that our suppliers, at least have a plan that can show us that they're also taking these steps to reduce their carbon emissions. And this is a requirement to be a supplier. So, maintaining business, it's going to help drive that as well.
Sure. And the same thing, are you seeing that flow down from customers as well? Like you're pushing it to your suppliers, or is it maybe not quite so apparent there yet?
It is, you see Volvo and other companies, and when they brand all electric vehicles by 2030, 2035, behind that means not only an impact to the products that we're making, obviously, which is maybe another discussion how e-mobility affects heat treat in general, but but that they're also flowing down requirements for us. So we've taken that, and as a general goal, we've said, we want to be 20% less than our footprint was in 2019, and we have these stages and focuses for each stage or milestone, and how do we get to neutral by 2050? So we're driving it to our vendors, and we're also being managed by our customers as well.
Mm-hmm. Interesting. So you actually have a stepwise plan that reviews various aspects of your business to reach that goal.
Yeah, so we label not only factories but equipment, and a heat treat typically shows up. But what are our key users, our critical consumption departments or machines? And then we're taking this, and when we start with our highest consumer, highest footprint machine, and use this as a basis to drive technology change throughout the company. That's the approach. It's maybe lofty to say by 2050 we're neutral without some kind of plan. So that's kind of how we're approaching it. And it's interesting. If you break it up into chunks every few years, the focus now, once it's implemented, we say, well, what's next? So the next milestone, it requires everybody to collaborate and keep being creative, and even pushing some of our manufacturers and suppliers to keep producing ideas of their own.
Yeah, so interesting. It's actually worked into the fabric, shall we say, of your maybe not day-to-day operations yet, but it's at least at the strategic level. When you make maybe new investments in equipment, or when you're selecting new suppliers, etc., it's part of the discussion at least. And
it is.
Yeah,
absolutely.
Great.
We're seeing that in new investments too. Like you want to buy a furnace or some batch furnaces, or for example, and usually we say, well, gas fired is cheaper, so that's what the technology will invest in. But now we have several, I would say, requirements that we have checked off, anything and everything related to sustainability and investments. So whether it's a new machine, a relocation of a machine, removing a factory, what can we do to this existing or new equipment so that it's deployed as sustainable as possible? And this always has to factor in long-term strategy. So if that means purchase clean energy in the future, we get electric heating, even though initially up front it's going to cost a couple 100% more or something.
Right. So there's some thought into that, and then integrating even some maybe clean energy sources into the mix to offset some of the others. At least maybe not all at once, of course, but down the line, that's at least on the table for consideration. Have you seen any government incentives offered, maybe through tax incentives or tax rebates for certain investments, maybe from the state or federal level?
Not really. So far, we did not see anything yet. We heard about the heat pump right now initiative that was just became a law, but we don't know how much this will affect actually manufacturers and all that. But I wanted also to touch another thing. It also our customers. So when the designers, and I was talking about the materials and the need to change the material designations and to design materials more friendly for the environment, and when I mean by environment, actually for heat treat environment, so that we can all pollute less. But I was also thinking about the designers that can choose between, let's say, iron plasma nitriding, gas nitriding, salt bath nitriding. It's time for them to wake up, because when you choose the process and you have in mind consciously that it's not only bottom price, but it's also the environment around you, then you have to choose the best, most environmentally friendly process. And it will also spur the development for the manufacturers of the equipment. Hey, what can I do? How can I make the same process but much more user-friendly, much more environmentally friendly? So, it comes from unfortunately, we see so much copy and paste, so much processes that we used 100 years ago, just continuing being copy and paste in the new designs, the new applications. And that's something that if we seriously want to address the global warming, the pollution, we really need to look into that. This is the core. Because if the requirements will continue the way how they are, the heat treat industry will have very little, not only initiative, but very little power to change, because if you have specifications that are requiring gas carburizing, oil quench, all these old style processes and all that, what can you do?
Dr. Berman, you mentioned nitriding as a specific process, and we'll say it's a more cost-effective option than the others for case hardening. However, most of the time we see customers choosing ferritic nitrocarburizing instead of instead of nitriding. And of course, that requires a carbon source gas, endogas. And what are we doing with endogas? Creating CO and CO2. So it seems a bit contradictory that they would be using FNC or ferritic nitrocarburizing. Have you seen any motion or any demand from customers that would demand you to move away from processes like that, even though they are more cost effective? And moreover, do you see any changes in the demand for improvements in equipment, heat treating or otherwise, that are driven by that need?
I hate to be not positive on that, but unfortunately, there are definitely some movements. And again, one of the movements is when you have a definition between ion plasma nitriding and gas nitriding, and this definition is clearly states about using hydrogen and nitrogen, not using any gases. It is a clear move towards the environment. It is a clear move towards having a better environmentally friendly process. But unfortunately, it's not much that that people put as in the heat treat industry. From other industries, we have a lot of work done. So IBC by itself, so we do many different projects. So our last project with the Air Force and was environmentally friendly paint removal. So we developed a process that removes paint using water-based electrolytes that using ultrasonically activated technology. And this project is one of the best technologies for this year. So we are working a lot in changing people's minds, and we do see in specifically the DoD a huge drive to get more environmentally friendly. So the cadmium replacement, the chrome replacement, it's happening right now. So we work on multiple projects over there as being also not only heat treating, but actually surface engineering and coating company, replacing these processes by environmentally friendly ones. Majority of them are being done in the vacuum so that there is really no pollution, going away from tanks with harsh chemicals and creating a lot of contaminants. So this is a fairly solid trend in the government and in the DoD. Just replace, remove reorient on more environmentally friendly. So I definitely would be glad to see the same thing happening in the heat treat industry, where processes, I mean, where there is an approach. For right now, the approach is very spotty and limited. There is like no one body that can look at the whole problem together and map out. So what do we do? In the surface engineering world, there is a map. So if we want to eliminate hard chrome, there is a map. We map the technologies of interest, we map the applications, we map how we address it. We do a lot of testing, we do replacement, and there is success, huge success in the field. You know, at one of the big examples is, for example, landing gear. Years and years, landing gear was chrome plated, only chrome plated and chrome plated and chrome plated. And now landing gear is majority is HVOF sprayed with the tungsten carbide. So much better process, much more environmentally friendly process. And now new processes are coming in. There are even more because they will be done in vacuum. So there is a movement, there is a clear map and clear understanding how to deal with it. So when we started to deal with the depainting process and all that, it's again, it's effort, it's organized effort, it's funded effort. I mean, it's very difficult to do something, you know, on your own. But when you have a system, when you have pretty much an approach and a map, then you can pull small players together and you can achieve really big results, including big players too. But we know where we go. So one of the things, understand about where the heat treating is going and how we're going to fight all the contaminations and all the emissions. We have to have a map, we have to have a vision, we have to have all the aspects, they have to be over there. And then we has to be a team that actually addresses it and pulls everyone together.
And as you mentioned before, that team has to incorporate steel makers as well as engineers who will pick the right technology for the specific application, and then us heat treaters who are actually doing what has to be done. But we don't really have much influence on the actual product and on the actual technology.
Yeah, so until the customers really make it an initiative that's key to them, the demand for the changes in the equipment isn't there. And as
John,
you're
absolutely right. I mean, we have to have it's exactly the same thing. Like when there is a government body that outlaws certain things, everything starts moving. When the government body outlawed the chrome plating as a big part of life, the chrome plating industry is shrinking and the replacements are coming. When cadmium is considered a hazardous metal and to deal with it becomes extremely cost expensive, people are finding different solutions, and solutions that work or as good as cadmium or very close to that. And all this is being pretty much supported by the we work a lot in the SBR, Small Business Innovative Research. A lot of our programs were done over there. We are replacing hard anodizing by our plasma electrolytic oxidation that is being done in water-based, environmentally friendly conditions. There are no acids, and the performance of the coatings are much better than the hard anodizing. So this is all happening, and it is happening definitely because there is a pool. So, and there are two types of pool. There is a pool of our common sense, where it says, do we want to leave this planet as a trash box where our kids and grandkids will have to go with the respirators because the air will be polluted, everything will be horrible? Or we have our responsibility as citizens of this planet to do something about it. So that's one thing. And then another thing is definitely the government initiatives and the government approach how we can help by promoting it, by putting initiatives, by definitely putting some funds on doing it. So that's that's a common ground.
Real quick, before we close, while I have you, I'm also curious on your perspective of this topic. How do you see from different customers this machine specifications and such being updated to support everybody's initiatives to meet this crisis?
Yeah, so I think, as you mentioned just a moment ago, it varies largely by geography, right? Certain markets are much more active, not just through government regulations, but through the market conditions. They're looking for more efficient answers. So efficiency doesn't equal, CO2 reductions necessarily, but it certainly helps. If we're using less energy, it reduces the CO2 emission overall, assuming that it's fossil fuel based electric. But overall, I would say we're just on the cusp of it from our perspective. That said, we do have technologies that are already postured to accommodate this in the future. Mainly in the vacuum arena, just because they're electrically heated furnaces, and most of them have limited requirements for carbon-emitting gases, right? So even for, say, carburizing, we're not using endogas, we're using acetylene, and only in the specific amounts that are required for LPC, versus, or for low-pressure carburizing versus gas carburizing that, we're constantly basically cracking a natural gas and producing CO and CO2 just as a source gas. So from our perspective, we feel as though the technologies that are now available on the market are ready for this to happen. Thank you very much for joining us. We appreciate your time and input, and look forward to talking with you again.
Thank you, Rafael. Thank you, Dan, for inviting me.
Don, thanks for having me. A very interesting conversation. I look forward to keeping in touch with you and with Seiko to see what exciting products and processes you guys will be offering here in the future for this topic.